Okay, thank you. Um, welcome everyone.
Mhm.
Welcome everyone. Today we are back with yet another discussion. Discussion 3, day 2. We have Om Desai and Siddhant Desai, who will be our guest for today. Before I hand it over to them, I would like to introduce them. Siddhant Desai is a senior at the Academy for Math, Science, and Engineering in Rockaway, New Jersey. He is an avid nature lover and spends time outdoors cycling, hiking, and fishing. When Siddhant realized that climate change and global warming impacted all of the things he loved about nature, he knew he had to get involved. And that's when he started with a strong background in technology, programming, and artificial intelligence. He founded Samur AI, an organization dedicated towards using AI for social good. Through this organization, he was able to create a software that detects areas of deforestation and potential areas of reforestation using satellite data all over the world. Siddhant plays on exploring other ways to use modern technology to fight against climate change as a part of the pop movement. We also have Om Desai, who is a junior at Academy for Information Technology High School, New Jersey. He is a young scholar at Davidson Institute, USA, and a student of Columbia University Science Honors Program. He has a strong interest in leveraging mathematics and technology like artificial intelligence for social good, more specifically towards understanding the Earth's climate system and to create climate resilience during global pandemics or climate change disruptions. His research has been published in international conference proceedings. For multiple years, he has been recognized as MAPD, someone who is making a positive difference in the community by Davidson Institute. For the community movement, he started Young Students Teach Younger Kids as a founder of Team AIRO. He has formed and is leading the AI and Climate Advocacy Committee within FXB International, and is looking for like minded climate advocates with a passion for technology to join him. With that, I would like to hand it over to Om and Siddhant. Please go ahead.
Thank you. Thank you for the introduction, Dersha. It's incredibly exciting to be here, and I look forward to sharing some of the things that Om and I have kind of worked on and learned from our experiences over the last couple of years. So we'll start by, or rather, today's session will be focused on understanding how technology can be leveraged for social good, specifically in a climate perspective. So we'll start by looking at a project that we've worked on called Project Green that it uses satellite data for reforestation. Um, can you see my screen?
Okay. Yes, I can.
Okay, great. So, our idea with Project Green was to try to find a way to plant more trees. And we all know planting trees is very important for the health of our planet. Trees are crucial to filter the air and produce oxygen, and they also store carbon dioxide in their structure. Trees also help to contribute against the fight against global warming, and they store large amounts of carbon dioxide, which would otherwise be released in the air. And trees are also home to millions of different species of birds and other animals all across the world. And when we cut down trees, we risk endangering the existence of these species. So we decided to make a prototype that detects areas of planting trees. We noticed that a lot of people wanted to go out and plant trees, but the biggest problem that they were having was not knowing where to go and plant those trees. So what we did was we were able to combine 5 data sets and 20 dimensions using a software called Google Earth Engine, which basically is a data set of satellite imagery from across the world. And it gives us a lot of data about the image that we're looking at, such as the elevation, the density of vegetation, etc. And we were able to combine data from another satellite called the Copernicus project, which gives us important numbers like the vegetation index, the precipitation index, humidity, etc., that allow us to determine which areas are either urban or very densely vegetated forests, or just like parks or fields. And when we're trying to find areas to plant trees, the things that we want to consider is we don't want to plant trees in urban areas because it's usually private property and they wouldn't survive as well in an urban setting. We also don't want to plant trees in already densely packed forests. And that's because planting trees in a densely packed forest doesn't give the tree the best chance for survival, as it's competing with much larger and older trees for resources. So what we want to find are areas where there's low vegetation like grass or fields, shrubs, where you can go out and plant trees. So as you can see in this bottom image here, the initial step detects areas as either heavily forested, urban areas, and also excludes human maintained areas like parks, fields, golf courses. Oops. The next step on the right over here then combines the initial findings from step 1 with a artificial intelligent model, which improves the precision of what we had in step 1 by using multiple more data sets, geographic data sets that's released by the government, to tag each of the areas as either urban, forested, or sparse vegetation. So as you can see here, on the left, all the areas in red represent what the initial model detected as plantable. But on the right, the areas in blue represent what the more precise model detected as forestable. And you can see that there's a lot more detected as forestable on the left. And that's because the model on the right is much more precise and much more accurate in which the areas are to plant. So the next step was to kind of take the results of both of those prior steps and overlay them on top of each other, and then really zoom in on those images to get a high resolution picture to look at the area that we planted. So if we look at this image on the bottom, we can see that there's 2 main clusters where the model has detected to go out and plant trees. When we've detected these clusters, we will zoom in on them and produce a high resolution image like the one seen right above. And we can see from these images that on the left was an area where deforestation actually occurred, and the model has detected that this is plantable area. And on the right is farmland, but it's old farmland that's no longer in use. So it would be a great place to kind of salvage the land and replant trees all over. Now that we know where we can go out and plant trees, we also want to know which type of trees to plant. Different locations across the world have different weather, different amounts of rainfall, and different species of trees will thrive in different locations. So we input the coordinates that we determined from steps 1 to 3 into an online database called the Seedlot Selection Tool. And what the Seedlot Selection Tool does is it'll take the coordinates of our locations and it will give us a ordered list of trees and their survival rates. So once we have that list of survival rates, we built another machine learning algorithm that takes all the data from the seedlot selection tool, the 1-year volume monitoring, the elevation, the latitude, the longitude where it would work the best, the precipitation numbers, and we split it up into 4 categories of soil, climate, resources, and species. And we're able to use this machine learning model to give us a survival percentage from each of these species. So this is the target variable that we're looking for, survived, a percent survived. And it will tell us that, like, oh, if you plant, for example, an oak tree, it'll have a 55% survival chance. If you plant a pine tree, it'll have a 45% survival rate, etc. So, what we hope to achieve through this model is we want to make it open source. So anybody on the internet can go onto a website and, look at areas near their house where they can go out and plant trees and, really help in this goal to reforest the earth. And it can allow people that, want to plant trees, but either plant trees in areas where they don't have a good survival rate or don't know where to plant them, and increase the chance of success for a lot of these initiatives. And we just hope to kind of inspire others to use technology to make a difference, and hope this is the first step in a new revolution of using technology for climate change. So now I'll pass it to Om, who will be giving us a demonstration of one of the other projects that we've worked on.
Okay, thank you, Sid. It's very great to hear. Move on to talking about about the technology behind using AI to protect biodiversity and make a small demonstration. So let's begin. Okay, so can everyone see my screen? Hey, Sid.
Yep.
We can.
Okay, wonderful. So let's talk about biodiversity and how technology can help. So let's first basically talk about the outline of the project using AI to help with biodiversity. And so if you were here during the first, did talk about the basic project for AI with biodiversity. Basically, the general gist of it was, but conservationists often use camera trap data in order to identify when animals are coming by in a certain area and being able to take pictures of animals in an area. By taking a bunch of pictures automatically of animals in these different areas, that allows these conservationists to get estimates of animal populations. However, since the conservationists can't do this themselves for all the images that are taken, AI is often used to be able to classify between different animals, being able to tell which animal is which, and then record that in order to better measure and identify animal populations. Now, what our project comes in, what we're doing is, well, this AI, the one that's currently being used to identify animals, this AI has to be trained and it then has to be tested. So you have to train it in one area, being able to show it a lot of images, and then you need to test it later, then give it an image of an animal and have it detect which animal it is. However, if it's trained in a forest and you test it, it'll often work very well inside a forest, but outside a forest in areas where it hasn't been trained before, it can often not work that well, which is why our project is basically to identify animals no matter where the animal is or where the background is. So now that we've got the overview out of the way, let's talk about the technology. So what technology is being used? So first off, where are we getting the data? So we're taking images from freely available sources, groups that have compiled camera trap data, and groups that have labeled camera trap data with a lot of different images and animals. We're then using object detection and machine learning in order to be able to find the animal in an image, along with image processing. So we're using along with image processing. So basically the first step would be to find which the animal is in the image, then remove the background so that the animal can't be identified, and then, remove the background so that the background which area the animal is can't be biased, and so the animal can be identified no matter where it is, and then using machine learning in order to classify the image based on which animal it is. And so to do this, we're using programming languages like Python for the image processing and tools like Microsoft Azure to help train up the artificial intelligence program. Now, if you'll see here, this is just a bit more elaboration on the idea of a camera trap. Just showing, and you can see that basically there is a receiver, and when an animal walks by, a picture is taken here. So that's the technology that's being used, but how are we using it? So first thing we're doing, we're using image processing to identify foreground and background. So we're using Python modules like OpenCV in order to basically look at all the pixels in the image and being able to tell whether a certain part of the image is in the foreground of the image, or if it's, then we use neural networks and object detection to identify the animal. And so I'm going to talk more about what neural networks are very soon. But basically, they're a way for a computer program to learn from a lot of data and be able to make decisions based on all the data that it's learned from. So let's talk about what a neural network is. So it's not exactly a representation of the human brain, but it's somewhat modeled by the idea, thus why it's called a neural network. And you can see that a neural network is basically just a set of inputs and a set of outputs. And so each input is a neuron. And so you put in the image or a set of numbers as your input. And then for every input, it's multiplied by a value and then passed on. So basically some operation is performed on it at every neuron, and then it moves on, and eventually, after enough operations are performed, it's at the output, at which point you get a final result. It's made a decision on what type of image it is. Now, when you first start a machine learning model, it starts with random inputs. So basically, the random. However, as you train it more and more, as you give it more images, it starts to update these inputs in order to be closer to correct. So, for instance, if it was wrong the first time around and it knows how wrong it was, it can now update the model. It can change all the values here in itself to get closer to being right. This means that neural networks can learn from their mistakes and be able to get better at classifying things over time. So what we're doing with neural networks is image classification. We want to be able to take an image of an animal and then classify that image between all sorts of animals. So we can do a basic demonstration just by doing things like classifying between two images by gathering training data, small amounts of training data, and then learning from it. So let's go on to do that. So neural networks often might sound like a bit of a daunting concept, right? However, and they are somewhat difficult. They're a pretty new advancement, and there's a lot of mathematical concepts behind it. However, just to get an idea of the basics behind neural networks, we can use Teachable Machine by Google, which is basically a very simplified way of making a quick neural network classification model, and it can help demonstrate how training, testing a model works, and how this model can classify something. So let's go to teachablemachine.com and let's open an image process and let's open an image model. And so what this model will do is it'll basically just identify between two different images. So if you want to see the general outline here, you'll note that it's got class 1, class 2, and class 1 and class 2. And for each class 1 and class 2, it'll allow you to add a lot of images to it. After that, once you put in both classes, you can then train the model and it'll give you a preview and it'll show you how the classification works. So let's do a quick example project somewhat relating to biodiversity, right? So say you set up a basic camera trap in your backyard and you want to identify different animals in the area. So what sort of animals would you find in your backyard that would be important to distinguish from? Well, for instance, let's start with, say, a squirrel and a bear. So both are very different animals, and however, both could theoretically show up in your backyard. And it's important to be able to distinguish the two because there's very different consequences from if a squirrel gets or if a bear gets into your backyard, in which case it's a bit of a danger and has also been displaced from where it normally is. So now, once you've had your two classes, squirrel and bear, and we've decided that we want to classify between whether an image is of a squirrel or if it's of a bear, we want to add a lot of images. This is so that the neural network can basically learn which images are which. So basically, it needs to see a lot of images of squirrels, a lot of images of bears, and it needs to slowly update. Okay, this is what a squirrel looks like. This is what a bear looks like. So let's put in a bunch of images. Okay. Now, normally when you're training a neural network, you need a lot more image samples than this, but right now we're just doing a basic example model here. So next, let's put in a bunch of images of bears. Okay, so we've got a bunch of images of squirrels and a bunch of images of bears. So now what you want to do is you want to train your model. And now what's happening here is the model is using this as training data. So it starts out looking at a random image of a squirrel or bear, and it guesses randomly whether this image is of a squirrel or whether it's of a bear. Soon as it realizes I got this wrong or I got this right, it realizes, okay, this is kind of what a squirrel looks like, or okay, a squirrel doesn't look like this. So now it can start recognizing features, like it can see maybe a squirrel has a much larger tail than a bear. And so basically, this allows it to model all this data and be able to identify which animal is which. So let's quickly, oops. Okay, let's switch to file here. And let's choose an image of a squirrel or a bear, for instance. So oopsie-doo. Here we go. First, let's start with an image of a bear. So put that image in, and you'll note that it gives 100% for bear. Now, if you look at these images of bears, you'll notice that this image doesn't show up once in these images. The The program has created a mathematical model to identify whether an image it's never seen before is more similar to one of these images, or if it's more similar to one of these images. Now we can do the same thing with an image of a squirrel that the program's never seen before. So if we just take a quick image of a squirrel here, you can now note that it's given 100% for squirrel. And so you can basically see the basics of how a neural network works. It starts with a bunch of training data. It slowly learns from that training data and creates a model of which animal is which, and then it can correctly identify between squirrels and bears. However, this is still a simplistic model, and an actual full machine learning model would use a lot more data, identify these, and what we're working on would be able to identify these even without a specific background in mind, like a forest. So it would identify a squirrel even if the squirrel was far away from what it normally was, and it would be able to identify all sorts of different animals. So I hope this presentation enlightened you on what the technology behind using artificial intelligence to help the planet is. Me and Sid, but what we've both shown could help talk about what you need to know and how you could work to make a difference using technology. Thank you.
Thanks, Owen. So, that was a great introduction to the how to kind of get into using AI and ML for different types of good. I'm going to share my screen. So what we can look at are just some potential other ideas with Teachable Machine. So you can actually use a live camera feed on Teachable Machine to instead of uploading an image, you can turn your camera on and it will do a machine learning algorithm on the camera feed. So some things you can do with that is you can do a mask detection model. So the model would be able to detect whether someone is wearing a mask or if they're not wearing a mask. And obviously this has many real world uses. A lot of businesses earlier in the pandemic and even now require masks. And this would be a great way to kind of detect who's wearing a mask and who's not wearing a mask. What you can also do on Teachable Machine is you can use the live microphone feed. So you can make a musical tone detector that would be able to say that, like, let's say on a piano, you play a key. The tone detector would detect that, oh, this is a C sharp or a B flat. And it would identify that and let's say just make a mark. So that way you can kind of detect what keys are being played in a basic song. You can use a bird detector that would be able to tell you that, between these, what type of bird this is. And Teachable Machine lets you even track body movement. So you can track the motion of a body, and you can kind of use it as a tool for people that exercise or work out, as like a counter for jumping jacks or push-ups or sit-ups. It can actually detect a motion and then increment that count. So these are just some, few ideas of what you can do with Teachable Machine. The applications of it are limitless. It's a great free software for beginners to kind of meddle with and introduce themselves to machine learning and AI. And I'm glad we were able to kind of share it, and hope everyone was able to kind of understand how it works. So what we can do now is I've shared the link to Teachable Machine in the chat. And if everyone can just take like a couple of minutes to play around with it, maybe create a basic model and see how we can use Teachable Machine. Me and Om can go around, answer any questions on either one of our presentations or Teachable Machine. And yeah, help out with any questions or problems that you might be having. So we can take like 10 or 15 minutes just to do that, and see where we are in that time.
Um, Siddhant, can you start a fresh teachable machine window and show us while we do it?
Yes, sure. So I can start it up, and then we can kind of do um like a follow with my screen.
Okay.
Okay, 1 second. I'll be right back. 1 second. Okay, so we open up Teachable Machine, and the project I'm going to do is going to be the mask detection project. And I'll kind of run through it here. Please feel free to stop me and ask any questions, and also follow along on your own computers if you would like. So since we want to detect whether we're wearing a mask or not, using the camera feed, we would be picking a image project and standard image model would work. So we have two classes, right? We want to see if we're either masked or unmasked. So class 1 would be masked people, and class 2 would be unmasked people. And in each of these classes, we want to upload data from, we want to upload data that corresponds with the class. So for the masked class, we want to upload images of masked people, but we can also take those images live. So if we click this webcam button, it'll open up a webcam on the screen right here. And what you can do is you can put a mask on. So I'll put a mask on here. And we'll take image samples from the webcam itself. So you want to kind of move around, get all the different angles. And as you can see, we took 84 image samples in that quick time. And those 84 image samples are here in this class called masked. And then for the unmasked class, we want to do the same thing. So we'll open up the webcam and we will take images of me unmasked. So, and again, same thing, try to get all different angles so it knows, this is like an unmasked face versus what's above is a masked face. And now that we distinguish between these two classes, we can train the model. But let's say we wanted to do more than just two classes. Let's say it was a different type of project, such as detecting the tones. We would need a class for each of the different pitches that we're trying to detect. So for example, we would need a C sharp class, we would need a B flat class, we would need a sharp class. So we can click the add a class button here and add as many classes as we need. But for the sake of this example, 2 classes is sufficient. So we can go ahead and delete this one. And now that we have our images, these are called training data because it's being used to train the model, so the model can make a prediction. So we have 84 images in the training data for the masked class and 78 images in the training data for the unmasked class. And when we go ahead and train the model, what it's basically doing is it's parsing through each of these images and detecting what's common between the masked class and what's not common between, or what the difference is between the masked and the unmasked class. And as we can see here on the right side, there's a live webcam that displays what I'm doing, like my situation. So right now I'm unmasked, which is correct. But as you can see, when I put a mask on, the model would detect with great accuracy that I'm wearing a mask. And same thing, as soon as I take it off, it detects that I'm unmasked. So this is just one kind of example of how you can use masked versus unmasked data to create these predictions. And if, for example, you want to integrate this into another program, you can use the export model feature, and this will give you the code to integrate this into different languages such as JavaScript or Python, and you can kind of incorporate this into websites or other softwares.
Can I ask one question in between?
Sure.
So, you try and cover your face with something else, some other piece of cloth, will it show?
So, for example, if I cover it with my face, then it's not detecting it as a mask. But if we take a similar, sheet that's blue like this, then it would detect. Even if I just hold this up, it's still detecting it as a mask. And that's because although 84 image samples is or sounds like a lot, to make a very accurate machine learning model, we would need thousands and thousands of images. And we would also need to train the model with, we would also need to train the unmasked class with putting different sheets of paper, like putting your hand or putting like a cloth over your face so that it knows that this is not a mask, right? For example, let's say we wanted to detect cloth masks versus surgical masks or N95s, and we wanted to distinguish between those. We could add a class for surgical masks. We could add a class for cloth masks. So that way we would also get data as to who's wearing what type of masks.
Okay, sure. You were telling us about exporting the model.
Right. So yeah, I was just saying that you could export it and integrate it into other programs, websites, softwares, or even like cameras or hardwares, kind of like what our biodiversity project is doing. And there's endless potential with Teachable Machine. So I'd be happy to answer any questions relating to any of her projects, Teachable Machine. Yes, Kevin.
Yes, I have two questions. So the first one is through the you showed an image where there was a camera in a forest and also this machine that sends the signals. So could it be replaced the camera with a cell phone? So can it work, for example, in the forest using a normal cell phone?
Do you wanna answer that?
So yeah, so you might not get the same quality of images, and it's going to be hard to actually get like a massive amount of images just using cell phones. Because if you want to train a machine learning model you'd want to get. It is possible to do so.
Yeah, one of the limitations of a cell phone is the rate and storage of images. So to train a machine learning model, it would take thousands and thousands of images, and the quality and storage of a cell phone may not be enough to kind of kind of keep up with that pace of image taking and storage. But for smaller scale projects, absolutely, cell phones would be very viable for that use.
And what about, for example, using an online platform like this one you showed us? The cell phone just take the images and send it, and the online platform makes the distinction if it's a bear or a squirrel. Can that happen?
You're muted.
Okay. Yes, it can.
Yeah, so you can upload it live and get that live distinction. But the one problem that you might run into is to get the live distinction, you're going to need access to a cloud, which requires some type of cellular service or satellite service, which may not be available in all parts of like forests and jungles. So getting the live feedback would be very possible, but in some cases you might need to just save those images and then upload them later to get the distinction.
Okay, perfect. And I have another question. Have you got any sponsor? Is this been applied already on a forest?
Okay. Okay, we do actually have a sponsor. We have a grant from Microsoft right now to work on it. Hasn't been applied fully because we're still working on developing a prototype, but we are working on applying it soon.
Yep, and we're also with Project Green. We'll soon be working in Connecticut, in the United States, to test it on on a neighborhood there. That would be the first kind of outsourced test of that model.
Okay, perfect. Yeah, and during COP26, United Nations presented a project they're going to run by 2025, and that one is focused on water. So they have a lot of data and they want to analyze many things. So I think this could be really interesting for them because on 2025 they want to launch a new project. So if it's already tested, I think I would encourage you to look for it. It's focused on water, so I think the Water Institute is the one who's looking for it.
Okay, that sounds like a great idea. Thank you. Are there any other questions?
Yeah, I have a question. Sorry. So when I clicked on export model, it also showed me that I can transfer already created model in that. So it's like having a code which I can merge with it, or suppose I have created a train model for some other activity which is linked to a new activity, and I downloaded that model, and now I upload that model into this one by transferring it. So will it function together? I don't know if you got my question.
Yes, actually. So that's exactly how it would work. They would function in unison. The code, when you click export model, the code that you see is what pairs your program in Python or JavaScript with the model itself. So you could actually run a code to interact with that machine learning model. For example, let's say you wanted to count how many people walk in wearing a mask versus unmasked. You could have the model detect whether someone's masked or unmasked, and then write a simple code that increments itself in two variables to see like how many people are masked, how many people are unmasked. Does that kind of answer your question?
Yes, it does. Thank you. I have a question from Om as well. So you mentioned that you are taking data from the Google Earth, right?
Yes, for the tree
So
project.
can you explain us more about how the GIS data is actually taken, referring to your project itself?
Okay, now, so basically, yeah, no, talking about the tree project, right? We're just using an API to be able to access that data, be able to gather the data from the general area. So yeah.
So
So yeah, please.
yeah, so what we would do is if we've identified an area where we want to see locations around it, we can input the coordinates of our area, and we can get a 25-mile radius of satellite data around there, or 10-mile radius or 50-mile radius, depending on how far we want to look. And we can see all of the plantable areas in that radius.
So suppose I talk about some water body, and we want to detect whether the color, based on color, um, based on the color, I want to distinguish it whether it's a sea bridge or some pure water body. Okay, so can you show us a demo how you actually project and identify that by picking anything now, if that is easy for you to do now?
So since so Google Earth Engine actually takes a very long time to create models, just because it's parsing through thousands and thousands of sets of data. So it's not something that we could do right now. But it's definitely an application of Google Earth Engine, and in sometime in the future we can kind of create a model to demo that.
Okay, so do you think that there will be open sources available, like open files available to actually create models for something like this? And can you give us any links or tell us more about some links from where we can directly download those sets?
Yeah, so Google Earth Engine is actually open source API. You need to get approved by Google, which should be which would be free, since you'd be using it for some type of social good purpose. But there's a whole application that you could fill out for that to get a free membership onto Google Earth Engine, and I can drop the link to that below right now. There's also another great satellite data source called the Copernicus project. And basically this has right here. So I'll drop the link to this one as well. This data set has a lot of information about the satellite imagery, so you can get data like, what's the humidity, what's the elevation, is it a water body, is it a freshwater body, saltwater body, and you can kind of use Google Earth Engine in union with Copernicus to make the best of both data sets. So those are the two best satellite data sets that are free and open source API.
Okay, thank you, Siddhant.
Of course.
That was really helpful. I think Ivan has a question.
Yes, thank you. So my question is related to cybersecurity. When the technologies applied to the people wearing mask or don't wearing it. Does it save like personal or specific face features, or just like general features to know that that's a person? Because I don't know, there has been some issues in China specifically about having their facial features recorded by the government and all that stuff.
So that's a great question. The intention of the model is not to record. It's more of a live feedback system. However, anything relating to cameras can, depending on what the application is and who is programming it, can be used to record. But the intention of a model that would detect something like face masks would be just to see like a live feed. It would see, oh, this person walked through the door, they're wearing a mask, they can enter. But then that data would be erased from the system as soon as the next person walks in through the door.
Oh, that's perfect. Thank you.
Yeah.
I think we don't have any other question, and it's about time as well. So thank you so much, Siddhant and Om, for this great presentation today, and we value it very, very much. I also wanted to propose to you that we have a team of CFR. I think Wade dropped out of call, but he was interested in inviting you both for one of his events that he wants to do with his organization. I think Ivan can tell you more about it. But we wanted to connect you both with them as well.
Yes,
Yeah,
totally.
that sounds like a fantastic opportunity. It was our pleasure today to present. Thank you so much.
Thank you.
Thank you so much. I will let them know and connect you.